my amazing students. This is Mrs. A, and I love math. And tonight we're working on more on systems of equations and test of functions in lesson 87 of our Saxon Orange book. So here we have a problem that has four unknowns, but we'll see in a minute that they're not all unknowns. We have R-E-T-E, R-W, T-W. So I'm thinking maybe that's a rate and a time, although they don't say it. Rate times time of E is the same as rate times time of W. So then they do give us some more information. They say R sub E is 200 and R sub W is 250. And another piece of information, T sub E plus T sub W is 9. And we're to find out what T sub E and T sub W are. So the first thing we're going to do is make some substitutions. So we can easily take R sub E is 200 and put R sub E right here. So R sub E is 200. So that means that 200 T sub E is equal to 250 T sub W. Okay, so that right there made this no longer needed. Okay, and so we have this equation and this equation, two equations and two unknowns. So the easiest way to do this is to use substitution. So I can either go ahead and substitute T sub E in terms of T sub W, or T sub W in terms of T sub E. So let's just solve for T sub E since it's sitting right here. I'm going to divide this side by 200, and I'm going to divide this side by 200 to get the T sub E by itself. So we have T sub E is 250 divided by 200 T sub W. So I'm going to go ahead and simplify this. So the zeros can cancel. 25 over 20 is 5/4. So we'll say 5/4 T sub W. So now everywhere, I'm trying to get that light off my screen. It's either too dark or it's shining. So we're going to say everywhere we see a T sub E in this equation, we're going to put 5/4 T sub W. So here's my T sub E, and we're going to put 5/4 T sub W. So 5/4 T sub W plus T sub W equals 9. So we have condensed everything to one equation, but there's only one unknown now. So 5/4, and then can we just change this 1 to 4/4? So 4/4, because that's the same as 1. 5/4 plus 4/4 TW is 9/4 TW. So we have 9/4 TW equals 9. Well, can we get rid of the 9s? Can we divide both sides by 9? So then we get 1/4 TW is 1. I divided both sides by 9. Well, now I'm going to multiply both sides by 4, and I'm going to get TW equals 4. So TW equals 4. Okay, so now let's go back and start substituting in. If TW is equal to 4, then 5/4 times 4 is 5. So TE is equal to 5. And TE plus TW is the same as 5 plus 4, which is 9. So we have solved. Now we could have done the same thing, but instead of solving for TE in terms of TW, we could have solved for TW in terms of TE, and we would have got the same answers. TW is 4, T sub E is 5. Isn't that fun? Okay, these are fun. This looks like rates and times again. But we are given that R1T1 plus R2T2 is 360. R1 is given to us as 30 and R2 is given to us as 40. Then we're also given that T1 plus T2 is 10. So we're to find T1 and T2. Now, these look complicated, but they're really not at all when you start to substitute what you already know. So let's put the R1 as 30 and the R2 as 40 into this equation. So we have 30 T1 plus 40 T2 is 360. Now, just for the sake of making things a little bit easier on me, could I cancel a 10 out of the whole thing and say 3T1 plus 4T2 is 36? Certainly I can simplify. I can divide both sides of an equation by any non-zero constant, and that's what I did. So now I have another one. T1 plus T2 is 10. T1 plus T2 is 10. Now this one is not really in a great form for elimination. However, we could eliminate. We could multiply this one down here by a -3, and we could use elimination. Or we could solve for T1 in terms of T2, or we could solve for T2 in terms of T1. So this lesson is mostly about substitution. So we're going to work this one with substitution, but you could do this with elimination by just multiplying this whole thing by a -3. Oh, let's do it. Okay, I'm going to multiply everything here by a -3 all the way across. So we end up with a -3T1 minus 3T2 equals -30. This one and this one cancel. 4T2 minus 3T2 is T2. It's a 1T2, isn't it? 36 minus 30 is 6. T2 is 6, and we found that by elimination. So T2 is 6. T sub 2 is 6. Now, we could do that with elimination. That's not really the way they set this lesson up, but it works to do it that way. So now we found out that one using elimination, but let's go back and put in our variables again. So I'm going to go ahead and put in 30 T1 plus 40 T2 equals 360. Okay, and I'm just going to go ahead and make it easier. Divide by 10, divide by 10, divide by 10, because I like things as simple as I can get them. And then we're going to use the T1 equals. So I'm going to solve for T1 here. T1 is 10 minus T2. So I am using substitution. I'm solving for T1 by subtracting by T2 on both sides of the equation. So I have a substitution equation here to go into this one. So now I'm going to slide this one into here. So here I have written the skeleton of this equation. 3T1 plus 4T2 is 36. But now instead of T1, I'm going to slide in the substitution for T1, which is 10 minus T2. Okay, so here we go. 3 times 10 is 30, minus 3 times T2 is 3T sub 2, plus 4T2 is 36. So now I've got a 30 over here and a 36. So what if I just subtract a 30 and subtract a 30 on that side, and then I'm going to combine these two together. And I'm going to get 4T2 minus 3T2, which is 1T2. So on the left, I have T2, 1T2 is T2, and on the right, I have 6. Now, isn't that what I came up with before when I used elimination? I used elimination, and I got T2 as 6, and I got T2 as 6 doing it with substitution. So it really doesn't matter which one you use. And I can very quickly go back up here and find out if T2 is 6, then what does T1 have to be? Something plus 6 is 10. So we know T1 must be equal to 4, and we have our equation. But let's check it. Let's go back up here. Is 3T1, so that's 3 times 4 is 12. plus 4 times T2, and 4 times 6 is 24. So 12 plus 24, is that equal to 36? And it is. And so we have solved several different ways, and we know that T2 is 6 and T1 is 4. So let me just hold that for you a little bit so that you can get any notes that you missed on that one. That was a fun problem. Okay, so here we are in the second part of lesson 87. We're talking about the vertical line test. Now remember, a function has only one y value for any given x value. And the vertical line test helps us to visually determine if that is so. A vertical line test tells us that any vertical line intersects a function at most one point. So if it is a function, then a vertical line will only cross the function one time at most, okay, per sweep. Now, if we had a point that didn't qualify as a function, if we had something that did not qualify as a function, like a circle, okay, and if I were to look at that point and that point right there where they intersect, this, let's just suppose that this is an x of 0 and a y of 0. So we're thinking of this as being right on the axis here. 0, 0. Then this point that's way up here is going to be twice the radius of the circle above it. So let's say that this is 0, 10. It's right above the other point, isn't it? Okay, now let's think about it. Anytime I have a point above another point, don't I break the function rule? Because the function rule is a function has only one y value for any given x. So here I have a given x of 0. And that given x of 0 has two different y values coming out. 0, 0 and 0, 10. Since that happens, it is not a function. So anytime a vertical line is crossing a function or a graph of a relation more than one time, then we have this situation where we have two y's for a given x. That is not a function. And that's called the vertical line test. The cool thing about the vertical line test is it's so easy to use that you don't have to know much about math to be able to use it. You just need to know that if a vertical line crosses a function more than one time, it is not a function. It's a relation. That is not a function. It is a relation because a vertical line crossed the path of the function twice. Had two intersection points. In fact, it had 1, 2, 3. Well, it's definitely not a function, but it is a relation. Now look at this one over here. Here we have a graph, and it is a function because no matter where I draw a vertical line, it only crosses the path of this sweep one time per slice. Okay, what about this one right here? Not a function because I can draw a vertical line in several places and cut the path of the relation more than one time. Therefore, this is not a function, this is not a function, but this one is a function because there's nowhere that it doubles back over. See, this one doubles back over on itself. This one doubles back over on itself. In fact, it makes an S shape, doesn't it? An inverted S shape. So, not a function, not a function, yes, a function. And that is the vertical line test. All right, so here we have a system of equations, and we're going to solve. Here it says to solve for the values of all unknowns. Okay, well, this isn't an unknown because they tell us what it is, and this one is not an unknown. So we're going to solve for T1 and T2. All right, so let's start here and start replacing the R's with what we know. So R1 is 3, so this can be 3T1 equals R2 is 6 T2. Okay, so could we do 3, 6? Could we divide by 3 and divide by 3 and say T1 is twice T2? We could do that, couldn't we? All right, and then we could substitute back in there. Since we have T1 solved for, we're going to put T1 right there. Let's just slide it up there. T1 is twice T2. So take out the T1 and put in twice T2. 2T2 plus 1T2 is 3T2, and 3T2 is 60. So let's divide by 3 and divide by 3 on the other side. T2 is 20. Now let's go up and solve for the other missing variable. Okay, so let's go back to this one right here. We know that T2 is 20. So twice 20 is 40. So isn't T1 equal to 40? All right, so we need to go back to this original one up here. Say, okay, let's check it. If R1 is 3 and T1 is 40, and R2 is 6, and T2 is 20, we get 120 equals 120. That one works. So let's go to the other equation. And remember, this used to be a T1. So let's go back to putting a T1 there. T1 plus T2 is 60. When I add those two together, do I get 60? I do. I hope you did that. I didn't tell you to go do it by yourself. You should have done that by yourself. That was a practice problem. Okay, here is a practice problem. So I want you to do this one by yourself. Now notice that we have RO plus RS is -1. Okay, so we have a negative number in our equation, but that's okay. We've got R sub O times T sub O equals R sub S times T sub S plus 16. And R sub O plus R sub S is -1. We're given that T sub O is 8 and T sub S is 4. So let's go up here. T sub O is 8 and T sub S is 4. Okay, so we're substituting in what we already know. We also know that R sub O is R sub S plus R sub S is -1. So let's go ahead and we have, let's do it a little differently here. We have R sub O almost by itself. So we're going to substitute a little bit differently just because it's fun to do so sometimes. We're going to divide by 8 on this side, and then over here we're going to divide the whole thing by 8. So we have R sub O is R sub S times 4 plus 16 divided by 8. We're going to take all of this and substitute it right there. So we're doing the substitution kind of backwards, but is it still going to work? Absolutely. Okay, so here is R sub O. We've solved for R sub O in this form. So now in place of R sub O, I'm going to write all of that. So I'm going to rearrange it a little bit. Instead of R sub S 4, I'm going to write 4 R sub S plus 16 all divided by 8. That's R sub O plus R sub S. Now R sub S, I'm going to write as 8 R sub S over 8 because I'm getting my common denominator there, equals -1. All kinds of ways we could do this. All right, so now let's go ahead and join these together. So we have 4 R sub S plus 8 R sub S, so this can be 12 R sub S plus 16 all over 8 equals -1. Now, I could simplify this, or I could do it the easy way, which is multiply both sides by 8. That's what I'm going to do. I'm going to multiply this left-hand side by 8. I'm going to multiply the right-hand side by 8. So now these 8s are going to cancel. And I'm going to get 12 r sub s plus 16 is negative 8. But I want r sub s by itself. So I'm going to subtract 16 from both sides. And when I do so, I've got a negative 8 minus another 16 is going to be a negative 24. Okay, so now I've got 12 r sub s is negative 24. 12 r sub s is negative 24. We'll divide both sides by 12, and I get r sub s is negative 2. R sub s is negative 2. Now, we're going to check these in a minute, but I don't want you to get stuck in a rut as to only one way to do this, okay? So now we're going to go find r sub o. And r sub o is going to be negative 1 minus r sub s. So what is negative 1 minus a negative 2? Isn't that plus a 2? So r sub o should be 1. Now, let's check. All right, let's check. So we're going to go back to the original equations. So remember, back at the beginning, I got to go back and look at it, and I've mutated them so. We had r sub o times t sub o equals r sub s t sub s plus 16. So let's see. Okay, we had r sub o t sub o. They already gave us that was 10. Well, it was 8. Is equal to r sub s t sub s plus 16. So before we divided by 8, this was our original. That's an 8. That's a 4. So we have r sub o is 1. 8 times 1 is 8 equals r sub s is negative 2. So this is going to be negative 8 plus 16 is 8, and that side is 8. It works. So then we look over here. R sub o plus r sub s. When we add these two together, do we get a negative 1? Yes, we do. And it works. So that was a little bit different way to work it, but it's a correct way to work it, and it works. Okay, so here we have 3 different shapes, and we're trying to figure out if they are functions or not. Okay, now this one, if I draw vertical lines through it, I only slice it one time for each time I draw a vertical line. My vertical lines aren't very good. But if they were truly vertical, like they are in the book, you only slice once. You only hit it once when you're slicing vertically. So this is a function. This one is not a function, okay, because I slice, I cut it twice. You only have to break the rule one time for it not to be a function, and that breaks it a lot of times, an infinite number of times. Therefore, this one is not a function. It is a relation, okay? And then this one is a function because whenever I slice it vertically, I only cut it one time. Therefore, yes, this one is a function. We are done with lesson 87. And this is Mrs. A, and may God bless your day.